Assalamualaikum warahmatullahi wabarakatuh. Today our group will present the assessment 2 for calculus 1. Our selected topic is application of differentiation. Our selected subtopic is graph of rational function. Our group name is Dynamos and the members consist of Nashili Izrin binti Nasruddin and me, Nohidayah binti Muhammad Zaki. I'm Farisha binti Azizi and Muhammad Arif bin Zamri.
Now we get to the introduction. What is graph of rational function? A rational function is a function that is a ratio of polynomial. Any function of one variable x is called a rational function if it can be represented as fs equal to px over qs, where ps and qs are polynomial, such that qs is not equal to 0. We know that every constant is a polynomial, and hence the numerators of a rational function can be constant also, but not that the denominator of rational function cannot be constant.
This is our problem statement. Given a function f(x) equal to x plus 4 over x minus 2, x-intercept is negative 4 and 0, and the y-intercept is 0 and negative 2. A. Find the vertical and horizontal asymptote of f. B. Find the interval where f is increasing or decreasing. C. Find interval where f is concave up or concave down. D. Sketch the graph of f using above information. So, to find vertical asymptote, first you need to take the denominator equal to 0 from the fx and find the x. If you look right here, the denominator is x minus 2. So, let x minus 2 equals to 0. Move the negative 2 to the right side, and we will get x equals to 2. For the analysis of vertical asymptote, as limit x approaching 2 to the left side, x plus 4 over x minus 2, that means it is equal to negative infinity. As limit x approaching 2 to the right side, x plus 4 over x minus 2, that means it is equal to positive infinity. For vertical asymptote, we need to find the limit. Limit as x approaching plus minus infinity, which given x plus 4 over x minus 2. To solve this, we should recall that we have to divide the highest power of x that occurred in the denominator. In this case, we will have to divide with x. So each of the term at the numerator and also denominator, we have to be divided with x. So we have something like limit x approaching plus minus infinity, x over x, plus 4 over x over x minus 2 over x. Limit x approaching plus minus infinity 1 plus 4 over x over 1 minus 2 over x. So subtracting the value of x with infinity will give us 1 plus 0 over 1 minus 0, that is actually 1. So that means y is equal to 1 as horizontal asymptote is 1.
Now I'm going to explain how I find the derivative of the function fs equal to x plus 4 over x minus 2. First, I will find the derivative of fs using the quotient rule formula. In our function, us is the numerator, which is x plus 4, and vs is the denominator, x minus 2. Now let's differentiate us and vs. u prime s equal to 1 and v prime s equal to 1. Next, we apply the quotient rule. And then we simplify the numerator. We get f prime x equal to x minus 2 minus s minus 4 over x minus 2 square. We cross x, positive x and negative x, and we got negative 6 over x minus 2 square. Now I will explain the critical and analyze where the function is increasing or decreasing. We set the numerator of the derivative equal to 0 to find the critical point, negative 6 equal to 0. Clearly, this function has no solution, which means there are no critical point where the derivative is 0. Next, we examine the denominator to find where the function is undefined. Setting the denominator equal to 0 gives us x negative 2 square equal to 0, we get x equal to 2. This tells us the function has a vertical asymptote at x equal to 2. Now, let's look at the sign of the derivative in interval, bracket at negative infinity to 2 and 2 to infinity. For x in negative infinity to 2, let's pick a test point, say x equal to 0. We replace x with 0 and we got negative 1.5. This means the derivative is negative. For x in 2 to infinity, let's pick x equal to 3. We replace x with 3 and we got negative 6. Again, the derivative is negative. Since the derivative is negative in both intervals, the function is decreasing, meaning we both use arrow down for this function, and except for the vertical asymptote x equal to 2. To summarize, there are no intervals where the function is increasing and the function is decreasing on negative infinity to 2, unite with 2 to infinity. So fx equal to x plus 4 over x negative 2 is always decreasing, except at x equal to 2 where it is undefined.
Next, to find whether the interval f is concave up or concave down, we need to find the second derivative. So from the first derivative, negative 6 over x minus 2 square, we need to use chain rule. So the answer is 12 over x minus 2. And then we need to make the numerator equal to 0. So from the second derivative, 12 equal to 0. So there is no solution for x. And then we need to make the denominator equal to 0. So we'll get x equal to 2. And then from the value of x, we can find the interval. So the first interval will be negative infinity to 2. And the second interval will be 2 to infinity. The test value for first interval is 0. So we need to use the test value into the second derivative, which is 12 over x minus 2. And then the sign we get is negative. So the conclusion is interval of concave down is negative infinity to 2. And then from 2 to positive infinity, the test value is 3. We need to put the value of 3 into the second derivative too. So the sum we will get is positive. So interval of concave up is 2 to infinity.
Okay. Assalamualaikum. My name is MAT183. So for today I'm going to be explaining to you how to sketch a graph of axis of information, or in this case, window information. So we have our gated information. That is x integer is negative 4 o, and y integer is negative 4 if 2. While the vertical asymptote is x equal to, and the asymptote is y 1. So let's draw the axis for y and x. So we have our information, that is the negative 4 is intercept at negative 4 and intercept at negative 2x. So we have our vertical asymptote, that is x equal to, so around here 1, 2, yes, around here, erase this one, erase, and the same one is y equal 1 and here. So yes, so now we get to erase this part, erase. So after that we can have x equal to, and right here is y equal 1. What we just need to do is just connect these holes just slightly below this line. Sorry for my like that, and just mirror the same thing right over here. So we have the same graph on the slide. So thank you. Alright, okay, Assalamualaikum. We meet again, just that my face a little bit bigger. So for conclusion, I will conclude our presentation. So to sum up, in order to graph the rational function, we need to identify the vertical asymptote by letting the denominator equal to 0, and then analyze it by approaching the values from left, on, and right hand sides. Then for horizontal asymptote, we need to find the limit of fx. After that, we need to analyze the behavior of the slope using first derivative to determine whether the interval is increasing or decreasing. Lastly, with secondary derivative to find interval of concave up and concave down. And yeah, draw the graph. Thank you. Okay, so we meet again. So, reference. We have our Law A Rowley E, Law A 2024 March, etc. 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 Well, I think there's much explanation to do here. So I think that complete our presentation. And thank you for being with us along our ride. And see you soon. Bye. Thank you.